Somewhere off the coast of Alaska, a king crab is walking across the seafloor. Wide, armored body, long, spiny legs, heavy claws out front. It looks exactly like the thing you picture when someone says the word crab. It is not one. Turn a female king crab over and you can see a giveaway. The flap folded beneath her body, her abdomen, is visibly asymmetrical and twisted to one side, where a true crab usually carries a more symmetrical one. That crooked shape is a leftover. King crabs sit in a branch of anomurans closely related to hermit crabs, whose shell-carrying ancestors had soft, asymmetrical abdomens curved to fit inside spiral snail shells. Over time, that lineage reduced its dependence on borrowed shells, folded the abdomen beneath the body, and widened the carapace into something that looks like a crab from almost every angle. And this is not a one-time accident. Depending on how you define the shape and draw the family tree, a crab-like body has evolved independently at least 5 times across decapod crustaceans from different starting plans. A British zoologist noticed the pattern more than a century ago and named it Carcinization. Nature, he wrote, kept making attempts at a crab. He meant it as a technical description. It has since been adopted as a threat. So the question is not whether it keeps happening, it does. It is why this shape keeps getting reinvented by lineages that did not inherit it from one another. To answer that, you have to be precise about what crab-shaped means. Take a lobster. Long, segmented body with a thick, muscular abdomen ending in a fan. That abdomen is not decoration, it is an engine. A lobster in trouble snaps it forward beneath the body and shoots backward before a predator can finish its attack. Shrimp and crayfish use similar tail flip escapes. Now, take a crab. The abdomen has not disappeared. It is reduced and folded tightly out of sight, and the rest has gone wide. The carapace spreads into a broad shield, usually wider than long, the legs extend outward, and the whole animal is low, compact, and armored. Different lineages reach it by different routes, but keep landing on that same combination. You could describe a king crab and a true crab with almost the same paragraph, yet they are not the same lineage. True crabs belong to Brachyura, where the classic crab body evolved. King crabs belong to Anomura, alongside hermit crabs, porcelain crabs, and squat lobsters. The two share older decapod ancestors, but king crabs arrived at something remarkably similar by a separate route, which means it is probably doing something useful, either an advantage under certain conditions or an easy route to reach, or both. And the fastest way to see what kind of life rewards it is not to look at what the fake crabs have, but at what they are still hiding. Start by counting their legs. A shore crab has 10 limbs in 5 pairs, claws in front, then 4 pairs of walking legs. Now count a king crab. Claws, then 1, 2, 3 pairs. 8 visible limbs. The last pair seems to be missing. It is not. It is reduced and folded up inside the shell near the gills, which it helps groom and ventilate. The same trick shows up in porcelain crabs, flat little animals in tide pools the size of a fingernail. They look crab-like, but are not true crabs, and their last pair is also tucked away, leaving 3 large pairs behind the claws instead of 4. Porcelain crabs give away something else too. Grab one by a claw, and it may leave the limb behind, detaching it cleanly at a special joint to escape, and regrow it over later molts. It carries real costs, but it is one more way to survive being caught when you cannot outrun anything. The larger logic starts with the part that gets reduced. The abdomen is a great escape system, but it takes energy to maintain and works best with room to move. In tight habitats among rubble and narrow gaps, a long exposed abdomen may offer fewer advantages and more surface for a predator to grab. So imagine a lineage spending more of its life there. If individuals with shorter, more protected abdomens survived slightly more often, that trait could spread over generations. The abdomen folds tighter, and the rest of the animal evolves as a wider, more compact unit. A broad, low carapace can act as a shield, in some habitats covering more of the body and fitting into narrow spaces between rocks, while the legs extend outward for easier sideways movement. That gives a different defensive option. Instead of a burst of speed, the animal backs into a crevice, lowers its body, and turns its claws towards the opening. The space becomes part of the defense, forcing any attacker to approach from the worst possible direction. For king crabs, reducing their dependence on borrowed shells may have paid off even more. Hermit crabs protect their soft abdomens inside empty snail shells, but they depend on finding shells of the right size and must keep trading up as they grow. Over time, their king crab relatives grew less dependent on those shelters, their abdomens more protected, the body more compact and armored. It was gradual, not a decision, but once shell dependence was gone, a major constraint on size and armor lifted. King crabs effectively walked out of the housing market and began carrying the house themselves. None of this required a plan. Each change accumulated on its own advantage. The result is not the best body possible, just one effective answer to a common seafloor problem. How do you avoid being eaten while living among rocks, crevices, and predators? When the same problem shows up again and again, a useful answer can appear more than once. So, if it works so well, why is everything on the seafloor not already a crab? Because it is not a prize. It is an answer to a specific question, and plenty of animals are being asked something else. A shrimp in open water depends on swimming and rapid escape. Take away its muscular abdomen, and you have wrecked one of its best defenses. A mantis shrimp follows another strategy, often living in a burrow and using powerful appendages to strike prey and rivals. Sometimes the answer really is to hit the problem. Squat lobsters sit in between, abdomens partly folded but not fully compact, showing carcinization can happen in degrees. The seafloor is not one habitat but thousands. Mud, sand, coral, rubble, caves, and cracks all reward different bodies, and the flat armored bulldozer only wins in some of them. The clearest proof that the shape is not a destination is that evolution can move away. Look at frog crabs, true crabs adapted for burrowing through sand. A broad, flat carapace is not always ideal for pushing through sediment, so their bodies are narrower and elongated, their abdomens less tightly folded and partly exposed. They are crabs becoming less crab-like. Researchers call it decarcinization, and it shows the form can be lost as well as gained. So evolution is not walking toward the crab. It moves toward whatever works nearby, and the crab shape is just one common destination, because many decapods start with similar anatomy and meet similar problems. Even the count is debated, depending on how researchers build the family tree and define crab-shaped, with some trees suggesting messier gains and losses than the classic number. The pattern is real. The tally is not, but the reason any of this matters goes beyond crustaceans. It is the same reason ichthyosaurs evolved bodies resembling dolphins, and dolphins evolved bodies resembling certain sharks. Those shapes were not inherited from a shared ancestor. Fast swimmers in open water all fight the same drag, and a streamlined body is one of the best recurring answers to it. Nobody is copying anybody. Physics is just short on options. The seafloor is short on options too, and decapods already carry the parts for the crab-like one: an abdomen that can shorten, a carapace that can widen, limbs that can shift, a shell that can harden into a shield. Give evolution that body plan, the right pressures, and enough time, and the answer can appear again. Convergence can look like evidence of a plan and is almost the opposite. There is no target and no memory of what another lineage already found, only inherited parts, local pressures, and a limited set of changes that work well enough to survive. Nature does not want to make crabs. It just keeps handing out the same test, and in the right habitats, the crab keeps being one very good answer. And in another strange corner of nature, cold oceans keep producing animals far larger than they should be. You can see why in the video on screen. Thanks for watching.